Good morning. In this session, we are discussing the introduction part of polarization of light. Coming to the review of plane of polarization. It is the polarization phenomenon that confirms the transverse nature of light. It is the polarization that proves light propagates in the transverse waveform. So according to Maxwell, light propagates as a transverse wave with electric vector E and magnetic vector B vibrating perpendicular to one another, and both are propagating along the same direction. So from figure we can see that the electric vector is vibrating in the plane of the screen and the magnetic vector is vibrating perpendicular to the plane of the screen, and both are propagating in the same direction. In most of the interactions with reference to light and matter, this electric vector plays the major role when compared to the magnetic vector B. The role of magnetic vector is negligible when compared to the role of electric vector when there is an interaction between light and matter. The phenomenon in which the vibrations of light restricted to a single plane is called polarization. Light is said to have vibrations in all possible directions. If by some means we restrict the vibrations to a single plane, then such light is called the polarized light, and the phenomenon is called polarization of light. So coming to the representation of polarized and unpolarized light, the first two figures represent the unpolarized light, whereas the first one represents light having vibrations in all possible directions, whereas the second figure represents light having two vibrations. The dots represent the vibrations perpendicular to the plane of the screen, and these arrows represent the vibrations in the plane of the screen. As in these two figures, multiple vibrations are present, so light is said to be unpolarized. Whereas in figures 3 and 4, light is confined or restricted to have single vibration. In the third figure, light is having vibrations perpendicular to the plane of the screen, whereas in the fourth figure, vibrations are in the plane of the screen. There are single vibrations in both the cases, and therefore light is said to be plane polarized. Whereas in figure 5, there are mixed vibrations. There are mixed vibrations again. In figure 1 and 2, there are equal number of vibrations, so it is unpolarized. But in the last fifth figure, there are unequal number of vibrations. Multiple vibrations are present, but they are unequal, and therefore it is partially polarized light. Partially polarized light. And here there is an experiment to demonstrate the transverse nature of light as well as the polarization of light. In order to demonstrate the transverse nature of light as well as the polarization of light, we consider two tourmaline crystals A and B, which are hexagonal in shape with their faces cut parallel to the optic axis. This line represents the optic axis. This is optic axis. The faces are cut parallel to the optic axis. We consider the unpolarized light. The unpolarized light is made to incident on one of the face of a tourmaline crystal A, which is hexagonal in shape. The light coming out of the tourmaline crystal, this light is observed to be slightly greenish in color, and the vibrations of this light is parallel to the optic axis, and the vibrations are single-sided. We can observe only one vibration of the light coming out of A, whereas light entering A will have multiple vibrations, which is unpolarized, and light coming out of A is having vibration in a particular single plane, and therefore this is the polarized light. Polarized light. Now, let us consider one more tourmaline crystal B, and if B is kept in such a way that the axis of both the crystals are parallel. If the axis of both the crystals are parallel, the light coming out of A will fall on B and it continues to propagate through B. No light is filtered off. The entire light coming out of A will pass through B without any change in intensity of light. Now, if B is rotated about the axis, about the incident ray's axis, considering the incident ray's axis, if B is rotated keeping A stationary, on the rotation of B, slowly the intensity of light coming out of B gradually decreases. At a particular stage, light coming out of B will be completely stopped, and light coming out of A will be completely stopped when the two axes are perpendicular to one another. And the axis of A become perpendicular to the axis of B, in the sense when the crystals A and B are said to be crossed. When the axes of both the crystals are at right angles to one another, then they are said to be in the crossed position. In the crossed position, no light will come out of B. Similarly, if we continue to rotate B in the same direction, the intensity of light gradually increases and becomes maximum again when the axes become parallel. So, for one complete rotation of B, the intensity of light coming out of B varies between 0 and maximum twice for one complete rotation of B. This confirms that light is completely plane polarized, and this also confirms the transverse nature of light. On one complete rotation of crystal B, if the intensity varies between minimum and maximum, then this light is said to be partially polarized. If the intensity varies between 0 and maximum, then light is said to be completely plane polarized. If it varies between minimum and maximum, then light is said to be partially polarized. If the intensity remains the same on the rotation of B, if the intensity of this light remains the same, then the light is said to be unpolarized. We have considered two tourmaline crystals A and B. A is called the polarizer. And B is called the analyzer. A is called polarizer because it produces plane polarized light. B is called analyzer because it analyzes or detects the plane of polarization of plane polarized light. It detects the plane of polarization. It detects to which extent the light has been polarized. So B is called the analyzer, A is called the polarizer. Now, and here it is represented. This is the polarizer and this is the analyzer. The crystal that produces plane polarized light is called polarizer, whereas the one that detects the plane polarized light is called the analyzer. Now, coming to the plane of polarization and the plane of vibration. We have considered a tourmaline crystal, and an unpolarized light is made to pass through the tourmaline crystal. The emergent light is found to be plane polarized, having vibrations in the plane of the screen. Now, the plane containing these vibrations, the plane containing ABCD is the plane that contains these vibrations, and this plane ABCD is called plane of vibration. Plane of vibration is the plane containing the vibrations of plane polarized light. And any plane which is perpendicular to this ABCD, or any plane which is perpendicular to the plane of vibration, is called plane of polarization. That is, EFGH is the plane of polarization, ABCD is the plane of vibration. Thank you.